All right, let's go ahead and take a look. We're doing our first day review, which is chapters 1 through 3. So let's go over just some general information. This week you're going to be working on, or through next week, kind of the final from fall 2011. So we'll give you some good practice with problems that you could see. So the first 13 questions, so numbers 1 through 13, are due Thursday. And then the last 13 questions, so 14 through 26, will be due next Tuesday. Which is the 18th. And then this one is May 13th. There's 24 multiple choice and numeric entries, so kind of like your quizzes, right? So you're either going to enter a number or you're I guess it could be a letter too, etc. Which graph is correct. It could be multiple parts to it or multiple choice. There's a 2.5 hour time limit. So remember, I'm going to give you a class on Thursday, May 20th to do it. And then we have that excusal form for 7th period, or your other option is to stay after school. So you'll have to do it all in one sitting. So this 2 hours is all one sitting. Do you get a note card? Nope, we don't even get a formula sheet, but you can make your own. By that I mean hey, at the beginning of the test, we've done sometimes, write down those things we think are important. So then as you're going through the test, you'll have them. What happens is if you fail the final, remember, if you fail, the highest grade you can get in the class is a D. Take a moment to check your grades in Skyward and Slick. Hopefully they're updated, but it's possible they may be a little outdated just because I am out on maternity leave. So I apologize if that's the case, but do take a look still. If your score is better on the final than your midterm average, then I'll count it as a 4th midterm just to kind of help you out. And then at the end of the semester, I will drop your lowest 3 homework assignments and your lowest quiz grade. So how should you prepare for the final? I would look at your previous exams, right? I'll say previous midterms. You can look at your quizzes. I think the quizzes actually are good because they have the same format as your tests would. And then additionally, you can look at hey, there's previous finals also on campus. Look at your notes, form a study group, right, etc. We're going to spend kind of 3 days in class going over some key things as well. But that doesn't mean we'll see everything, right? Okay. So this first part, I just thought it's hey, if I was going to take this test, what are the key things that I would want to have written down, etc.? And this is kind of what I came up with. So whether you do it at the beginning of the exam or you just do it as you go through, okay, first thing we want is a trig chart. So at this stage, we should be pro at filling this out. I think you know it fairly well, especially sine and cosine, because that's the one we use the most often. Even tangent, we definitely see a fair amount. Okay, well, it's totally up to you for these other ones. I do kind of recommend, making it a little bit further just because you will see, remember we had those problems that were arc sine, arc cosine, etc. You'll see those as well. So I think having the whole chart there will help you out just to make sure that you have it all together. You have it all together, yeah, you know it all. So remember with cosecant, you want to think about doing 1 over sine. So that may be helpful, 1 over sine. Maybe I'll write on the left a little bit more. So this one's undefined. And then we get 2 square root of 2, 2 squared roots of 3 over 2, over 3, sorry. And then we get 1. Secant is 1 over cosine. So then we get 1, 2 square roots of 3 over 3. If you rationalize it, I've always rationalized, you don't have to. And then we get 2 and undefined. And then cotangent, think about it as cosine over sine. So we get undefined. And then we get square root of 3, 1, 3 square root of 3, square root of 3 over 3, and then 0. Okay, I just think that will help you as you go through. It's not to say you have to. Know your all students take calculus. In addition to that, I'd maybe even add in there like, hey, remember that these ones are where arc cosine exists, right? And then these ones are where arc sine and arc tangent exist. The only other one that's a little bit tricky, because like arc cosine and arc secant are the same spot, is arc cotangent. Is also kind of flip where it is, but I wouldn't stress too much about that. I think we use our regular first like 3 sine, cosine, tangent a lot more. Okay, your Pythagorean theorem identities. Remember, we've got sine squared of theta plus cosine squared of theta equals 1. If you know that, that may be enough, but I would even think in my head like, okay, what if I divide everything by sine? I get 1 plus cotangent of theta equals 1 over sine is cosecant squared of theta. If I take the original equation, divide everything by cosine, I should say cosine squared technically there, right? Tangent squared of theta plus 1 equals secant squared of theta. Are there other ways to write those for sure, but I think if you just have those 3 down there, it will help you kind of see, and you can always rearrange when you're in the test. So then we've got our sum and difference. So sine of alpha plus beta. So we got sine of alpha, then cosine of beta. Since the trig function switch, we keep the sign the same. That's how I kind of remember it. So then we get cosine of alpha, sine of beta. And then remember, if you do the opposite, if you subtract, you're just going to subtract as well. With cosine of alpha plus beta, we have cosine alpha, cosine beta. Since the trig functions do not switch, we switch the sign. Sine alpha, sine beta. So this one, it flip-flops the way you do it. I also always think about the double angles here too. So like sine of 2 theta. If I plug theta in for both alpha and beta, I simply get 2 sine of theta, cosine of theta. Same thing here, cosine of 2 theta. I end up with cosine squared of theta minus sine squared of theta. And yes, we can rearrange that. I think on the next time, I'm going to have you rearrange it as we kind of get started. Okay, your polar stuff. You've got x equals r cosine theta, y equals r sine theta, and then we've got x squared plus y squared equals r squared, and your theta equals arctan, or tangent inverse, of y over x. Okay, law of sines and law of cosines. Law of sines, I don't even know if you need to write this down, so you got like sine of alpha over A equals sine of beta over B. You guys seem really good at this one, so I don't know if you need this one as much, and then sine of gamma over C. Your law of cosines, I always think about it as like c squared equals a squared plus b squared, but it's a little bit different than Pythagorean theorems. You also have 2 minus ab cosine of gamma. And then we've got some area formulas. So there's 2 area formulas. Let's see if I can still have enough room over here, sorry. So for area, you can either do 1/2 of AB sine, because it's the y for the height of gamma, or remember we take like the semi-perimeter, we're going to do s, the square root of s minus a, s minus b. It looks like, sorry, we're going to have to do it a little bit more to the left. S minus a, s minus b, s minus c. and that will also give it 2. So it just kind of depends if you have angles or if you got sides. Technically, it doesn't matter because you could use your law of sines or cosines and either one would work. So just pick what you kind of like the best. And then last but not least, we've got a couple other things here. And maybe like really a few of these are, I mean, you can pick and choose what you want. So when I say optional for these ones, really all of it is optional. But De Morph's theorem says, okay, if I have z, let's say z is some complex number, a plus bi, then z to the n equals the modulus of z, so which we write kind of like, it looks like the opposite value, cosine I side of the theta times n. Okay, dot product. We usually write it as a times b for those two vectors. So vector A you can think of as like a1, a2 times b1, oops, sorry about that, b1 comma b2. So when we multiply them together, we're going to do the first components multiplied plus the second components multiplied. And then lastly, we're talking about the angle between those two vectors. I'll just call it, we're going to do cosine of theta, which I guess I'm going to write it just cosine of theta, and then you know, like, hey, to solve for theta, we could do arc cosine. We're going to do our two vectors, a times b, all over, so that's the dot product, all over the magnitude of a times the magnitude of b. So just remember that's the dot product. Okay, I think those things will help you as you go through. It kind of just gives us one place to keep referring back to, and you'll kind of see how much of those you need to, like, hey, keep looking at, or hey, you know, I actually know this. So let's go ahead and start. Degrees to radians. They want you to be familiar with both. You should also be able to graph an angle, but in all honesty, I think we've done so much of that, I don't think we even need to review it. So let's go ahead and look at applications. So basically, remember, it's unit conversions, cancel things out. At what speed in miles per hour does a bike travel if the rider can cause a 26-inch diameter wheel to rotate at 103 revolutions per minute? Round the answer to the nearest tenth of a mile. So we're going to do miles per hour. So we start off and we've got 103 revolutions per 1 minute. Okay, let's start by converting to hours. So we got 60 minutes in 1 hour. Okay, that cancels out. We now have hours. Now we got to get to miles. So for every 1 revolution, we want the circumference of the circle. So the radius is going to equal 13. Actually, it's actually nice they gave the diameter here because the circumference is just 26 pi. In this case, inches. Okay, so our revolution cancels. I now have inches. And then I've got, hey, there's 12 inches in 1 foot. So 1 foot, 12 inches. Notice how I had to put inches on the bottom such that it cancels out. And then they gave you one other conversion there. 1 mile over 5,280 feet. Those cancel out as well. So now it's just kind of multiplying and dividing. So 103 times 60 times 26 pi divided by 12 and 5280. So we end up with 7.967, but it says the nearest tenth of a mile. So we're going to have to round that up to 8 miles per hour. Okay. If you're doing this in class, then I'd have you try this next one, but since I'm just making a video, let's go ahead and go through. We've got 2,700 revolutions for 1 minute. Once again, let's convert minutes to, because we're looking for miles per hour. So 60 minutes in 1 hour. And then we're going to do 1 revolution. This time it gives you the radius. So since it gives you the radius, we're going to have to do 22 pi inches for the whole revolution because that's the circumference, 2 pi r. And then we're going to do 1 foot is 12 inches, and 1 mile is 5,280 feet. So like minutes to hours, inches to feet, they expect you to know, but like the mile conversion, don't ever worry about memorizing. Then you go ahead and you multiply that out. So 2700 times 60 times 22 pi. We divide it by 12 and the 5280. And we end up with 176.715. So we're going to call that 176.7 miles per hour. Okay. We already filled out the table on the first page. You need to know that, right? We also need to know that secant is the opposite of cosine. Cosecant is the opposite of sine. Cotangent is the opposite of tangent. And then be able to apply that knowledge in other cases. I always think in these cases, like when in doubt, draw a picture. I think if you have a picture, it helps you see what's going on. So find the exact values of the other 5 trigonometric functions if angle alpha, if cosine of alpha equals x, and we're in the fourth quadrant. Okay, so in the fourth quadrant here, this is a theta, this is our alpha, sorry, not theta. So cosine is adjacent, which is x, over hypotenuse, which we could put x over 1. Which means this last side, if we use the Pythagorean theorem, we get 1 minus x squared. Whether you think to yourself, okay, all students take calculus, so therefore cosine's positive here, but everything else is not, or you add a negative here, right? So either add the negative to the square root of 1 minus x squared, or all students take calculus, make sure you're careful about your signs. Okay, because we're in the fourth quadrant. So, sine, if I now do this, opposite over hypotenuse, sine, we're just going to get 1 minus x squared, but it is negative. So negative the square root of 1 minus x squared. Okay, cosecant is the opposite of sine, so we're going to do negative 1 over 1 minus x squared. Okay, tangent I'm going to do, and then I'm going to do cotangent. So tangent is opposite, which is the negative square root of 1 over 1 minus x squared, all over x. So cotangent's the opposite of that, x over the square root of 1 minus x squared. And then finally, secant will be positive, because that's the opposite of cosine, 1 over x. You try this next one. So once again, we are in the fourth quadrant, so we're doing a positive 12 and negative 5. If you use the Pythagorean theorem, 12 squared plus 5 squared, take the square root. We get the square root of 169, which simply equals 13. Okay, so sine then for theta is negative 5/13. Cosine is 12/13. And tangent is negative 5/12. As you do these opposite, it just flips them. So cosecant is negative 13/5. Secant is 13/12. And cotangent is negative 12/5. Okay, got some word problems here. A guy wire is 1,000 feet long attached to the top of a tower. So we got 1,000 feet. We got this tower. So this is like the tower. It's okay. And it makes a 43-degree angle with the ground when pulled taut. How tall is the tower? So let's start with that. How tall is the tower? So in this case, since we've got opposite and hypotenuse, we're doing sine of 43 equals x over 1,000. So we're simply going to times by 1,000. And 1,000 sine of 43, we end up with nearest tenth. So we got 68.2, in this case, feet. Okay. The next one, though, if we want to look at, we've got, let's say, now it says, how far is the base of the tower from where the wire hits the ground? So let's call it y. So that would be cosine of 43 equals y over 1,000 times both sides by 1,000. So 1,000 cosine. Oh, sorry, I totally on that last one. I did not, when I typed in my calculator, I did not do an extra decimal. So it's actually 682. So then on the next one, we do 1,000 cosine of 43, we get 707.1 feet. Okay, you try this next one. Kristen is swimming in the ocean and notices a coral reef below her. The angle of depression, so this is Kristen swimming, right? The angle of depression is from the horizontal line looking down. So this is 35 degrees. Okay. And the depth of the ocean at that point is 250. How far away is she from the reef? So we're looking for this. So she's looking down at the reef here, and this is where Kristen is up here. Okay, so in this case, we got tangent. We got tangent of 35 equals 250 over x. What do you think about cross multiplying or timesing both sides by x? We then get x times tangent of 35 equals 250. So we divide both sides by tangent of 35. So 250 divided by tan of 35 gives us 357.04, we'll say, feet. Usually it tells you what units to round to. Most often they tell you to round to either the tenths, which is 1 decimal, or the hundredths, which is 2. Okay, let's look at this next one, because I think sometimes you get in the word problems, you're like, oh, these aren't too bad. But this one, we want to look at how it's different. So it says a hot air balloon between two spotters who are 1.3 miles apart. One spotter reports the angle of elevation to the balloon is 65. Okay, so from here to here, we've got 65. But then from the other guy, this angle is 72. The other reports is 72. And they are 1.3 miles apart. So they're now asking you what the altitude is of the balloon. So we're trying to find this x. So notice it's a little bit different because I don't just have a straight old triangle here, right? Like I can't just do like sine, cosine, tangent. I'm first going to start by finding this angle up top. So 180 minus 65 minus 72, and I end up with 43. The fact that we know that the top is 43 degrees, I'm actually going to need to solve for one of the sides before I can find the height here. So I'm now going to choose, it doesn't matter which one, maybe I'd choose this left side, sorry. I'm going to find y and then solve for the altitude. So to find y here, we're actually going to need to use the law of sines. It's probably the easiest. So sine of 72 over y equals sine of 43 over 1.3. So I think it's important to recognize, hey, just because you start getting in this habit doesn't mean that all the problems are the same. So like notice how this is pulling stuff from another section. Okay, we all know how to solve for y, so then we type it in. 1.3 sine of 72 divided by sine of 43. We end up with y is equal to 1.8, the nearest tenth. So I'm just going to call it 1. Well, I can do a few more. 1.813. Okay, now that I have this side, let's think about what that really looks like. So if I look at this triangle on the left here, I got that this is 65. I'm trying to find x, and I know this is 1.813. So now I'm just doing sine. I'm saying sine of 65 equals x over 1.813. So times both sides by the 1.813. So sine of 65 times 1.813. equals 1.643. But it says the nearest tenth, so we're going to just call it 1.6. In this case, miles is the altitude. So just make sure as you go through, it looks like here in this case, the way they have you rounding, you could have rounded this up here to 1.8, and that would have been fine as well. Okay, trig identities. So we want to go ahead and make it a single trigonometric function. So that means that we really should just have one trig function at the end. So let's see what we got. 1 plus cosine of x tangent of x cosecant of x all over 2 cosecant of x. Okay, right now I just noticed, hey, you may start and be like, oh, I can just cancel the cosecant. So the problem is you can't because it's 1 over that, right? So I'm going to start writing things in terms of sine and cosine. So we got 1 plus cosine of x times sine of x over cosine of x times 1 over sine of x. Oh, hey, look at that. Your sines cancel, your cosines cancel, and this is 2 cosecant of x. Okay, so now on the top, I have 1 plus 1 over 2 cosecant of x. That's really 2 over 2 cosecant of x. The 2's cancel, and I have 1 over cosecant of x. So I can either say, okay, well, I know what the opposite of that is, or I could think about it as 1 over 1 divided by 1 sine of x. So as I invert and multiply, I simply get sine of x. And that is just one trig function. Prove this next one. Okay, so there's a couple of different places you could start here. You can either start on the left or the right. I kind of feel like I like that left side better. So 1 minus sine squared of x for 1 minus sine of x. Here I'd probably notice, hey, that top is the same as cosine squared of x. And on the bottom, while I can't simplify it, I should be able to recognize that I can times that by 1 times sine of x and end up with something that may help me out. So I've got cosine squared there. Times 1 plus sine of x all over 1 minus sine squared of x. And I actually made this harder than I needed to, but that's okay. And then I got cosine squared of x times 1 plus sine of x. And on the bottom, I get cosine squared of x, so those cancel out. I'm left with 1 plus sine of x. Okay, so then 1 plus sine of x, I can rewrite. So notice how we have cosecant over cosecant? Let's try breaking that apart. So cosecant of x over cosecant of x is simply the 1. And sine is the same as 1 over cosecant of x. So therefore, if I combine those, the common denominator, I do get what they were asking for. Okay, I realized I just made this a little bit harder than I needed to. I could have started by factoring, and it would have saved us a little time. But notice, hey, that's the cool thing about trig functions is there's lots of different things that do work out for us. Okay, let's take a look at graphing. I put some little notes over on the right there to remind you about what the different transformations do. But let's first just look at what's the graph of sine of x. So remember, sine of x looks like this. Cosine of x starts at 1 and then comes back up. And then tangent's the one that's a little bit funkier because it has asymptotes at like negative pi halves and pi halves. So it looks something like this. Okay. Sine and cosine are the ones that we use the most often, I think, because you can see the amplitude so well. Tangent, not as much. And even like your cosecant, cotangent, secant, they don't use quite as often. So on this first one, we want to go ahead and write an equation. So I usually start these and I'm like, okay, well, where's the center? It looks like it's shifted up 1. So if I think about this equation, maybe I'll just write over here on the side. That b is what does the vertical shift, and it's up 1, so it's going to be positive 1. Okay, the next thing I maybe look at is I'm like, okay, well, how often does it occur? So this looks like sine. That's what we want it to. It starts kind of like that's where our 0 is. And the next time it stops at pi here, right? So notice from here to here, I've done a full period. So if my period is pi, remember 2 pi divided by omega, right? 2 pi is your normal period of sine, has to equal pi. So that implies that omega equals 2. Okay. So the next thing we got to decide is, did it shift right or left at all? No, what they call is a phase shift. And then the last thing is the amplitude. So I look at how high this is. This has an amplitude of 3, so that means A equals 3. Okay, I'm ready to go ahead and plug these things in my equation. So I've got S of x equals 3 sine of 2x, plus we didn't shift right or left at all, so I could say it's plus 0, plus 1. In this case, you could rewrite that and just call it, hey, 3 sine of 2x plus 1. However, just be a little careful there, like if we're inputting, if they ask you for like what A, B, omega, phi is, you're going to have to put in a 0. And then last but not least, one for you to try. So I gave you this equation. And this equation, remember you do want to have it in factored form. So this is actually going to be x minus pi halves when I factor out that 2 plus 3. So your amplitude hasn't changed. There's no number in front, so it's just 1. It's like your A value. Your period here is how often it's occurring. So usually it is 2 pi, but in this case I have another 2. So my period is simply going to be pi. If it helps, think about this as 2 pi divided by where the omega is in the equation. This is like your B. Your phase shift in this case is going to be the factored form. So it is that pi halves. And when you do x minus pi halves, that does go right pi halves. So we are going to leave it positive. This is your horizontal shift of right pi halves. If it was left, you'd want to make it negative. And then frequency, I wouldn't worry about this one. But it's saying, how often it happens per 1 unit. But it's saying how often it happens per 1 unit. So you basically do 1 divided by your period, which in this case is 1 over pi. All right. That takes us through what we're reviewing today. Next time, stay tuned for chapters 4 through